am not, I just want to set some expectations for this talk. I've given it several times now, and I really do enjoy it. I hope you do too. And containers really apply to everyone, not just, my background is Java, but also, obviously it applies to other languages as well. This is not going to be a tutorial on how to use Docker, really. There's a ton of documentation out there already about that. So when I put this talk together, initially, I just wanted to do something a little different. I wanted to dive in with some research and focus more on how we got here and get some answers to those big why questions. Why do we even do this? That said, excited to share with you the things that I learned about containers. And of course, they're all the rage right now. And my hope is that you come away with a better understanding of the history behind containers, how they actually work on your system, and some of what is really going on under the covers. So again, if you have any questions, I don't know, I guess you can throw them in the chat.
Yeah, I'd say throw them in the chat, or if you want to, feel free to find a space,
or just
a natural space
yourself.
to unmute. I think it's cool.
All right. Well, super important. I'm not going to speak too much about this because Ari's already got you hooked up with our raffle and everything. But this is where my slides will be and where the video will be posted when it becomes available. So just a little bit about my background. My name is Melissa McKay. I started with JFrog as a developer advocate in February of last year. So this means I'm coming up on my year anniversary, which is pretty exciting. I do come from a developer background, and I've been a developer for over 20 years now. Most of my experience has been in server-side development in Java, but I've had the privilege of working on many different teams. And over the years, a variety of different technologies, languages, and different tool sets, including Python in my most previous position. I've been on large teams, small teams, big companies, small companies, had my share of frustrations and successes, I'm sure, like all of you have, and discovered along the way a passion for diving in deep to understand things and share what I've learned and hopefully improve some of our processes along the way to make our lives easier. Obviously, this fit in really well with JFrog's goals for developers, so I was pretty happy to put my hat in the ring to become a developer advocate and start this portion of my career. All right, so this is some time to fill up the chat a little bit. Who is using containers right now, and what are you using them for? I see some hands. I'm gonna fix my view here because I don't see very many faces. Okay, here we go. This is much better. All right, this is like a little poll question that I put out a couple times when I've given this talk. I just find it interesting to know how people are using containers, and not everyone is using containers in production, but there are plenty of other reasons to use them, specifically around testing or around staging and QA environments. They do ease a little bit, setting up developer stations and environments, getting everything consistent across the board. So they're pretty valuable to learn. And if you haven't touched a container yet, I definitely advise you to start looking into it because they don't seem to be going away. So today I'll start with a brief history to give some background context. Hopefully that part won't be too boring, but there's some really important milestones in the past that are important to know. We'll take a look at the container market and what's been going on there in the last few years. And I'm really excited. I haven't yet, but I want to update. I want to find out what's been going on just this previous year. Then we'll move into getting a real understanding of what Docker is. Docker is not synonymous with containers. That's important to understand. After that, we'll be in an excellent place to talk about what a container actually is. Then we'll review a few common container gotchas, some I've fallen in myself along the way when I first started. Last but not least, I'll talk to you just a little bit about an option for managing your container images. So without further ado, let's jump in and start learning about containers. So I know some of you are wondering if you're in the right place because this is not the picture that you would expect for a container talk. It's not the classic shipping container photo like you usually see. There's a couple of reasons I chose to go with the banana theme. First and foremost, I'm just tired of seeing shipping containers on every presentation about Docker or containerization in general. So I've started a rebellion, and hopefully you can enjoy it a little bit with me. Second, this is really a story about how our industry has adapted to dealing with limited resources over time. And bananas just reminded me of a story that my grandfather would tell me repeatedly when I was growing up. When he was a kid, he would get a banana once a year on Christmas. And this must have been during the 20s and early 30s. And back then, bananas were such a treat that none of that banana was going to go to waste. He and his siblings would take a fork and scrape the banana off the banana peel to get every last bit off. They knew they wouldn't likely get another one until the following year. So maybe that's not the best analogy to use, but I enjoy it. I liken that story to how computing resources were in the 1960s and 70s, which we know were very limited, very expensive. On top of that, it took forever just to get anything done. And often a computer would be dedicated for a long period of time for a single task or for a single user. So obviously, the limits on time and resources created bottlenecks and inefficiency. And just being able to share wasn't enough. There needed to be a method to share without getting in each other's way or having one person inadvertently cause an entire system to crash for all users. This need for a better strategy and sharing compute resources actually started a path of innovation that we see massive benefits and changes in our industry today. There's some key points in time that brought us to the state we're in today with containers. And I'm going to begin our history lesson with Chroot. Chroot came out in 1979. It was during the development of the 7th edition of Unix and was added to BSD in 1982. Being able to change the apparent root directory for a process and its children results in a bit of isolation in order to provide an environment, for example, testing a different distribution. Chroot was a great idea, solved some very specific problems, but more was needed. So at this point, jail command was introduced by FreeBSD in 2000. Jail is a little bit more sophisticated than Chroot in that it includes additional features to help with further isolation of file systems, users, and networks, and with the ability to assign an IP address to each jail. In 2004, Solaris Zones brought us ahead even further, giving an application full user, process, and file system space and access to system hardware. Solaris Zones also introduced the idea of being able to snapshot a file system, which you'll see becomes pretty important when we talk about containers. In 2006, Google jumped in with their process containers. These were later renamed C groups. That might be a more familiar term. That centered around isolating and limiting the resource usage of a specific process. Moving right along in 2008, C groups were merged into the Linux kernel, which along with Linux namespaces led to IBM's development of Linux containers. 2013 was a big year. Docker came on the scene. That's not when they were founded, it's just when people started to know about them. They came on the scene bringing their ability to package containers and move them from one environment to another. That same year, Google open sourced their Let Me Container That For You project, which provided applications the ability to create and manage their own sub-containers. From here, we saw the use of containers and Docker specifically explode. In 2014, Docker chose to swap out their use of the LXC toolset for launching containers with libcontainer in order to utilize a native Golang solution. That was something new that I didn't realize, is that Docker was written in Golang. So I'm almost done with the history lesson here. From here on, you'll just start seeing a ton of projects, organizations, specs, etc., that all get kind of confusing if you don't have a better understanding of how containers work, which is the point of this talk. Another event in June of 2015. This one is important to know about because it'll give you some insight into some of the activity and motivations behind shifts in the market. The Open Container Initiative was established. This is an organization under the Linux Foundation that includes members from many major stakeholders, including Docker, with the goal of creating open standards for container runtimes and image specification. So that is it for our history lesson. Let's move on to what's going on in the market. I did a little hunting and found that for the last 3 years, Sysdig, a company that provides really powerful monitoring and troubleshooting tool for Linux, many of you might already be aware of this, has put out a container report based on an analysis of their users. Part of the report includes data on container runtimes that are in use. In 2017, they analyzed data from 45,000 containers. There's no graph available for this one in the report because 99% of those containers were Docker. So they didn't bother splitting up the results. In 2018, though, you start seeing a little bit of a shift. They analyzed data from 90,000 containers, doubled the sample size. 83% were Docker, 12% CoreOS Rocket, 4% Mesos Containerizer, 1% LXC. So it looks like other container runtimes are starting to encroach a little bit. Moving on to 2019, the latest Sysdig container report included stats from over 2 million containers. Docker is still holding relatively strong at 79%. 18% is Containerd, but it's worth noting that Containerd is actually a runtime that Docker builds on top of now. The last 4% is Cryo. I don't know that there's enough data here yet to determine whether Docker will stay on top in the future or if something completely different will prevail, but that remains to be seen. This data is interesting, especially because of what happened over the last few years. Something to note here is the disappearance of Rocket. This is kind of a sad story. Happens a lot in our world. CoreOS was acquired by Red Hat at the beginning of 2018. And prior to that, Rocket was accepted to the CNCF as an incubating project and looked like a promising competitor to Docker's Containerd. However, since the CoreOS acquisition, the development of the project went dormant. In mid-2019, Rocket was archived by the CNCF, and in February of 2020, that project was ended. So now that I've introduced a few of these other container runtimes that exist out there besides Docker, it's time to start talking about what a container actually is, what Docker actually provides, in order to appreciate the differences between them. So what exactly is Docker anyway? This is key. What Docker had over other players in this container game was a focus on commoditizing a complete solution that made it easy for developers to package and deploy their applications. If you get a bunch of developers behind you, you own it, you own the world. So once containers became easy to use for developers, we all witnessed the explosion of additional tools and resources around containers. And the Docker image format rose to become a de facto standard in the market. The stats that I showed from Sysdig previously are specific to container runtimes. That terminology is important to understand here. It's just a part of the whole package. I'll explain those pieces and parts involved in working with containers, and you'll immediately understand why Docker sucked up this market so fast. So as users, let's think about what we actually need to get our apps out there and running. Every innovation that comes out of this space, it's purely based on either need or want, whatever the motivation is behind it. If a user needs or wants something bad enough, there's a huge opportunity there for solution providers like Docker. So often we can find ourselves in those nitty-gritty details that we lose sight of the actual problem we're trying to solve. And this leads to a ton of missed and overlooked opportunities. So here's a list of needs that are broken down into discrete features. And first and foremost, we need the container itself. Some of you might be asking about virtual machines at this point. Discussing VMs is out of the scope of this talk, but so I'm not going to go into deep differences. But the one thing I'll say is a virtual machine is not the same thing as a container. The biggest difference is that a VM includes the entire OS all to itself. Containers share the system's OS. The point of a container is to be lightweight and to have the ability to move from one environment to another seamlessly and quickly. That said, I know there's some developments happening now in the VM space, but that's a topic for another time. So the rest of this list will go pretty quickly. We need an image format to define a container. We need a way to build an image of a container. We need a way to manage images, a way to distribute and share these images that we have, a way to create, launch, and run a container environment. And then we need a way to manage the life cycle of a running container. And I didn't even get into orchestration or anything, but this is plenty to prove my point about Docker. So Docker was ready with an answer for all of these things at the right time. You want to start using containers, use Docker Engine. You need an image format? Well, here you go. Here's the Docker image format. You need a way to build an image. There's a simple command, docker build, and use a Docker file to do it. You want to manage images? Call Docker images or Docker RM for remove. You want to share your images or use an image from someone else? Call Docker push or Docker pull. And there's Docker Hub, extremely popular, where you can store and share all of your images. You need a way to launch, run, and manage your containers and their lifecycle? More simple commands for you. Docker run, Docker stop, or Docker PS. Docker succeeded in quickly meeting the immediate needs of this container-hungry market. So on top of that, the tool sets that Docker provided for developers especially made all of this extremely easy. Huge plus for developers. It was enough to walk away with a tremendous part of the market share all the way down the aisle, and I hope you appreciate the time I spent searching for a picture of bananas that made sense with this part of the talk. So remember in our history lesson when I spoke about the Open Container Initiative, out of all of those features that we just discussed that Docker offers, there are two that were taken up for the cause by the OCI, the image format and the container runtime. Docker did quite a bit of reorganizing their code base and developed a bunch of abstractions, pulling out discrete functionality. They are a heavy contributor to the OCI, and they gave the Docker v2 image spec as a basis for the OCI image spec. And runc, which was contributed as a reference implementation of the OCI runtime spec. There are quite a few other container runtimes you might see out there, including Containerd, and Rocket, Cryo, and Kata, all with various levels of features for specific use cases. It's worth pointing out that Containerd was contributed by Docker to the Cloud Native Computing Foundation, and that actually internally uses runc. Containerd has also been integrated into Docker, and Docker has been using it since version 1.11, which came out in 2016, so it's been in there for a while now. The next few years will be interesting to observe what happens with these specs and how the OCI moves forward. There's quite a range of differing opinions about what should and should not be in the standard for a container runtime. We're in a situation where using a runtime that just meets the requirements of the OCI spec doesn't seem to be enough to get enough momentum and get a user base like Docker was able to do with everything. I've added a couple of links here that I found in my research. They're excellent starting places to learn more about container runtime specifically, if you're curious. The second one is the beginning of a blog series by Ian Lewis, a Google Dev advocate. The first subtitle in that blog series is "Why Are Container Runtimes So Confusing?" which was clickbait for me. It's very true. Anyway, Ian does a really good job of succinctly explaining why some of this has happened, and he goes into details about low-level and high-level runtimes and how they overlap in some places. So what if you don't want to use Docker? You're interested in containers, but you're not interested in using Docker. Well, there are a few projects out there that are good attempts. Podman runs containers. BLOAT builds images. Scopio transfers container images from remote repositories. You might want to sit yourself down and ask why buck against using Docker. Maybe you just don't want to use the long-running daemon that Docker requires. Maybe you just want to stop thinking that Docker is all there is, and you want to stop calling all containers Docker containers. Maybe for some reason, for automation or whatever, maybe you just want to build your own images using a bash script. You can use a Docker file in these projects, or you can actually build images step by step yourself from the command line and put together the layers manually. The cons of this is it's just not very convenient. Not convenient to run on Mac OS or Windows, which is a lot of our development environments. Podman machine still requires a Linux VM, but that's the closest you're going to get to conveniently using these. Maybe you just don't want to build a container every time you are working with something or you're in the middle of development. You've got your code up. You don't want to build a container and test something. There is a talk that I saw recently by Jessica Dean. She's a dev advocate for Microsoft. And this project that she was talking about is called Bridge to Kubernetes. It was really, really cool. It allowed her to use an existing environment that lived, outside of her machine, and she could set up routing in such a way that she could do live troubleshooting with her code and set breakpoints and everything without messing with containers at all. Obviously, this still required containers in some environment somewhere. Also, you have to have your app set up in just such a way so that it will work correctly with that type of environment. Also, it was limited to Visual Studio and VS Code, which I used IntelliJ, so I was disappointed immediately. Also, you may have heard lately in the news that Kubernetes or the CNCF has chosen Containerd as it's a graduated project versus Cryo, which is another runtime, which is currently incubating. Also, Kubernetes is no longer going to support Docker, but that doesn't mean that you can't use Docker containers. It just means they're using the Containerd runtime. They're not using the Docker engine anymore. But that's still something that you can use as a developer. You can still produce images that are compatible, all of that. So there was a lot of panic because of a lot of these overloaded terms that people use when you discuss Docker. So now that we understand all about all of the Docker, all that Docker entails, some of what's going on in the market, let's just focus on the container itself and what that actually looks like on your system. I'll show you how it's stored and what is actually happening under the covers. You'll discover pretty quick that containers aren't really all that magical. So my first experience with containers was as a new developer on a project with a tight deadline. Of course, I think that's most projects have tight deadlines. And for me, the best course of action is usually just to jump in and start getting something up and running. I learn best by doing. And so the Docker documentation at that time was good. It's better even now. So definitely use that if you find yourself in a similar position. You want to pay attention to those docs. I read the whole thing. Just getting something up and running and working does not mean it's done well, and it can actually be a little dangerous and be pretty inefficient in some ways. So I don't know if you've ever thought yourself pretty clever as a developer, you got something working, but then you step back and realize just because you could doesn't mean you should have. That's happened to me a few times in my career. Pretty typical progression. The first thing to note is that the Docker image is really just a tarball of a complete file system. When an image is unpacked, it's on your machine. It's just thrown into its own directory, and which becomes its root file system. The second is that the processes that are involved in running the containers are just regular Linux processes. On top of that, there's just a few Linux features that are used together in a way to achieve the isolation that we want from containers. Namespaces are an important ingredient because this is what is used to provide the virtual separation between containers. This is how the processes inside the container don't interfere with the host or processes inside another container. Here, you can see some namespaces that were set up for a Postgres container that I have running on my box. The cgroups functionality is integral to constraining how much a container can use things like CPU, memory, network bandwidth, other resources. I can set these constraints by including options on the Docker run command when launching an image. Here you can see that I've constrained this particular image. I've constrained the memory usage limit here on one of my containers. I'll quickly gloss over some file system details here, where containers and images are actually stored on your file system. First off, after you've installed Docker, running the command docker info will spit out a bunch of information about your installation, including the Docker root directory. This is where most everything you're going to care about regarding your Docker images and containers will be stored. Note that if you're on a Mac, which I am, your containers are actually running in a tiny VM. So you're going to need to use a tool like Screen or something to get in there and get to the Docker root directory to look around. And if you're not familiar with how to use the screen command, do yourself a favor and Google that first, because it'll mess up your text display pretty good if you don't enter and exit it correctly. This slide shows how you can get information about the image that you have stored on your system. First, I just listed my available images using the Docker images command. And I actually have several installed, but only the first couple are displayed here in this list. Using the Docker inspect command, I can inspect any image I like using its image ID. This will spit out a ton of interesting information. But what I want to highlight here is the graph driver section, which contains the paths to the directories where all of the layers that belong to this image actually live. Docker images are composed of layers, which represent instructions in the Docker file that was used to build the image originally. These layers actually translate into entire directories on your system, and these layers can be shared across images in order to save space. The lower dir, merge dir, and upper dir sections are especially important. The lower dir directory contains all of the directories or layers that were used to build the original image. These are read-only. The upper dir directory contains all of the content that has been modified while the container is running. If modifications are needed for a read-only layer in lower dir, then that layer is copied into the upper dir where it can be written to. And this is what we know as the copy on write operation. It's important to remember that the data in that upper dir directory is ephemeral data that only lives as long as the container lives. In fact, if you have data that you intend to keep, you really should be utilizing the volume features of Docker and mount a location that will stick around even after the container dies. This is usually how most containers that are running or relying on a database are set up. Lastly, the merged dir is kind of like a virtual directory that combines everything from lower dir and upper dir. The way the union file system works is that any edited layers that were copied into upper dir will overlay layers in the lower dir. And the merged dir is what is visible to your container. This slide shows I have actually a few containers currently running on my system. Two of them are my local JFrog container registry installation, which includes a container for Artifactory and a container for a Postgres database. The other is a simple test container that I was playing around with. Note that the container IDs of the running containers match up with the container subdirectory names. If you're curious and want to go fishing around for specific files that belong to specific containers that are running. Something to remember here is if you stop a container, that corresponding directory doesn't just automatically go away until the container is actually removed with the Docker remove command. So if you have stopped containers lying around that never get cleaned up, you might see your available space start to dwindle pretty quick. There is a Docker prune command you can run every now and then. That'll help you clean things up. Or when you launch a container, there's a flag that you can use to indicate that it should be removed when it's finished running. And a lot of orchestration tools will have this available to you and put it in your face so that you do the right thing. All right, on to our gotchas. So all of these tool sets around building and running images and containers have made things so easy that it's also easy to shoot yourself in the foot in a few places. Here's some of the most common gotchas. I did include a JVM specific one. It's Java, and I'm sorry, I'm a Java person, so I'm forcing you to listen to it. You have friends.
We'll let it slide this time, Melissa, but next time I better be Python examples.
Okay. Well, if you have any Java friends and you hear Java containers, it'll click why there are problems. All right, so the first one, this one, running a containerized application as the root user. So I'll be really honest here. When I was initially getting my containers up and running, I didn't care. I was just so excited to get it working and get it running. It was a while before I took this one seriously. Now that you know that processes inside a running container are just like any other process on the system, albeit a few constraints, it's scary now to run as root inside a container. Doing that opens up the possibility of our process escaping the confines of the container and gaining access to your host resources. You should always be reducing your attack surface by following the principle of least privilege. Although containers are designed not to affect other running containers, if someone were to gain access to your container and then they immediately have root privileges, they can wreak havoc on your host, which affects everything that's running on your system.
Yeah,
So
on
how
this one,
to,
I have a quick comment on that because this is
yes.
a hard one to accomplish for local development, but much easier to do in production is what has been my experience with that. I don't know if you have tips for how to run locally to match up UIDs and GIDs so that when you write files to a volume or write files to the bind mount, that you get the files written with your permissions and not like root
And someone
permissions
else's,
or
yes,
some random
yeah.
UID that you don't have on your system.
Yeah, there's some default IDs that are used. Like, for example, I had a situation where I had one running and using the ID 1000. Well, someone on that box was assigned that ID to 1000. So yeah, that was kind of a pain to work around that. I think that's when I realized for the first time that this is an actual issue, because now this single person on this box, everything that this container was doing was running under that user, which was not good.
The other thing we've run into is when you're actually building the Docker image and you actually want to cache some things, such as like for Rust compilation, you'll have a cargo cache. And then when you try to do the UID hack to run that, you no longer have that cache and nothing's installed for custom pieces for that, which is kind of a pain.
Interesting. Yeah, that's pretty frustrating.
You can also have another problem in that you end up not being able to access files that were written by the container, right?
Exactly.
Which is actually almost worse. So yeah, running it as root in a container can be annoying too. So I think there is really no free lunch.
That is exactly what happened in my experience with it. And this particular user actually left the company. So when the user went away, we're like, huh, what do we do now? We kind of had to start from scratch. So yeah, mitigating this problem, make sure to, create users, use that user command inside the Docker file when the container is built in order to run processes as that user. I know that's simpler said than done because you've got the ID issue going on. But there are ways to get that up and running. Spend the effort and the time to figure it out for sure. There's a way to specify a user when you use the Docker run command. But again, that leaves open the possibility of forgetting to do that or attaching to the wrong ID. It's nice if the image is just set up by default not to run as root. There are some that are like this. Some official images that you pull from Docker Hub. Pay attention to those. Some of them will expect you to figure out what user to run them as. All right, moving on, no constraints. This was another issue that I ran into pretty quickly. Even though Docker provides you with the ability to set resource limits on your containers, it doesn't automatically do it for you. In fact, the default settings are pretty much a free-for-all with no limits anywhere. So make sure you understand the resource needs of your application. You can't be lazy, still have to figure that out and know what your application is doing and what it needs. If you have, too little resources, your container will die from starvation. Too much and the container could smother others on the system. The resource usage of your containers is something that you're going to want to monitor over time because it will change. You'll need to adjust as needed. It's a good way to determine if something is going wrong with your application or if load on your system has changed for some reason. Never updating your containers. This is an easy one to get into. This applies to a lot of things. Once you get something working, you just don't want to touch it. It's a pretty big security issue, really. It's easy to get complacent and not pay attention to what is actually getting pulled in when you build your images. Not only do you need to be aware of outdated versions you specify in your own Docker file, but you need to pay attention to what's in the base image that it's coming from. Not updating those packages and libraries inside of your container can lead to some pretty embarrassing results. And especially, there are a lot of tools now available that will alert you when security issues have been discovered with specific artifacts. So even ensuring that you're running containers with a non-privileged user has that risk when there are known vulnerabilities that exist within your container or even on the kernel of the host. From time to time, exploits are found that enable attackers to potentially escape a container. And unfortunately, that stuff happens and all you can do is respond quickly. And you need to have a process around doing that. So keep up with those security updates. I did have an experience where we had some containers running that ended up falling victim to the whole bit mining thing. And we were wondering what was happening to all of our resources on these boxes and noticed it coincided with every time we put specific containers on those boxes. So I've definitely been on teams where updating and keeping up with those security updates haven't been a priority. And that's primarily because of the fear of breaking a product or a service that's already working. That's a symptom of completely different problem and a whole nother set of issues. So trust me, it's much worse to leak private data or potentially be the start of some domino effect that brings an entire system down. I'm preaching to the choir, I know. All right, this one is Java specific, but just be curious why this is a problem for Java, especially older versions of Java. It's very much related to being aware of what your application requires to run regarding memory. The JVM is usually pretty clever at automatically determining settings for your swap and your heap and your garbage collection behavior based on things like the memory and the number of cores available. Well, considering that like Java 7 and Java 8 and versions of Docker came out like in overlapping times, and the result of this is that those versions of Java are not fully container aware. This means that Java applications won't necessarily obey those memory and CPU constraints that you thoughtfully put on your containers. And you get some pretty crazy out of memory killer activity there. The reason for that, the mechanisms that the JVM uses to retrieve the resources available come from the actual host machine and not the C group limits that you would expect. There were definitely improvements made in later versions of Java to improve that container awareness. I have more detail there, but I'm just going to say Java 11 is your best version to start with to get real reliable container behavior that you would expect. All right, container bloat, image bloat, I mean. Pulling in large parent or base images that include a bunch of stuff that you don't need. This is so easy to do. When you're just putting together a Docker file, it's just one line, you know, at the top of your Docker file from blah, blah, blah. And who knows what that's bringing in. So pay attention to what you're actually bringing in. Don't just pretend that these base images are magic. Someone made them, someone built them. Someone else determined what needed to be in them. It's a good idea to get as many of those as possible built yourself with only what you need in them to keep them small and also to reduce security problems really from libraries or packages that you don't even use but can ultimately cause some problems or reveal some vulnerabilities later on. The other thing that I see often is ignoring the Docker ignore file. There is a Docker ignore file, very similar to like the git ignore file, right? I've seen Docker files that copy the entire source tree of the project into the container. That means that it includes tests, it includes a bunch of stuff that you don't need. And there's multiple problems there. And one of you mentioned this earlier, you can actually be copying in some secrets unintentionally and not realizing it. Even if in later layers or later commands, you are thoughtful and delete those, they still exist in the underlying layer. You just can't see them from the top of the container. So make sure they just don't ever get in there to begin with. Also, I'll see like a copy of an entire source tree getting moved over in one line. That means if anything changes there, that layer has to be regenerated every build and every layer after it. So organize your code in such a way that the changes that happen the most often are in their own layer. This is, you know, you may have implementations versus abstractions. Obviously, the implementations will change a lot more often than the abstractions will, at least that's the idea. So be thoughtful in how you put these Docker files together. Another one is I mentioned the git ignore file. Well, by not adding your Git directory, you're actually, you know, you could potentially be copying in your entire Git directory into your container. And that's another problem. The other thing is using moving your build tool, adding your build tool to the container. That's not necessary. There's a multi-stage Docker builds where you can, you know, build and then take the result of that build and only that result goes into the container. Don't include all of the tools that you needed like Maven or whatever. I say Maven. I can't help it. But that's obviously not limited to just Java projects. All right, where are your base and parent images coming from? Are you specifying container registry in your Docker files, or are you always pulling from a remote registry by default? That's how Docker works. It always pulls from Docker Hub by default, unless you tell it otherwise. Are you specifying specific versions in your Docker files, or are you relying on getting the latest version by default? That definition of what latest is, it can be pretty tricky. Where are you storing your proprietary images? These are images you want to protect access to and not, you know, have available for all of the public to use and share. So public registries like Docker Hub have their purpose. They're an awesome place to share, but I highly recommend using a private internal container registry. This will give you more reliable access to required images for your builds. have a specific story here. We had a project that we were working with and weren't aware that one of the base images for these containers that we were using was coming from a repository that belonged to a contracted company that was no longer employed. So at one point, just all of a sudden, the builds broke. We needed to make a change and we no longer had access to that base image. So pay attention to that kind of stuff. There's a lot of tools available out there. Obviously, JFrog has its free container registry, which also supports Helm charts and generic repositories. And if you're curious how a container registry works, you want to try it out at no cost, JFrog has their free SaaS version that you can sign up for to play with and just see how it works.
Quick question. Does
Yes.
JFrog offer a public repository, container repository, just like the Docker Hub? Is there something
Yes.
like that you have?
There's several centers that JFrog offers. In fact, one that's coming up is we're going to be launching JCenter, which is pretty exciting in my world, if you can imagine. We also have, we've got several others. We have Go Center. We have a center for Helm charts, Chart Center. And
We host our Debian repositories there and just converted to paid. So, but you could be free for quite a while to host your Debians.
Yeah, I mean, I asked because obviously Docker Hub has changed their policy about free.
Yes, yep, that's definitely something and another reason why you should consider pulling in what you need and caching them at your, more local level rather than always reaching out to Docker Hub to get everything. I think there's going to be a lot of surprises in continuous integration pipelines and that kind of stuff, because I think oftentimes they're not using their local cache, and it's just a setting. Sometimes it's just like a Maven setting that needs to refer to your local repository rather than the public repository, or like with Docker, like I said, there's a from that just uses the default Docker Hub instead of the cached versions that you would have available. So it was so easy for so long and people started taking it for granted. So I'm curious to see what happens in the next few months, who's going to start paying more money to Docker Hub because they weren't thinking about these things. There's another resource here. This is just a ref card with dzone, very vendor agnostic. It's just something to read through, just considerations you should have when you're choosing a binary repository manager, and specifically a Docker registry. So that one definitely highly recommended. All right, that's it, guys. I hope you learned something new. Here's this QR code again to go and sign up and get a t-shirt or an Echo.